Okay, hello. Everybody hear me all right? Okay. See here. All right, good. Okay, so a couple of things. Um, we've basically covered all of the material that we're supposed to cover for the semester, and where we're at right now is going into review sessions for the exam, for the final exam. Um, Probably most of you remember from the introduction about how the final exam works, how many points it covers, um, where the second chance comes in, where if you do better on section 1, section 2, that will override whatever exam grade that you got from the first two exams. Um, I guess most of you did pretty well on those first couple of exams, so maybe it doesn't help you that much, but um, those are the main things that comes out from that. I'll share with you a couple of things. One, administrative, just to get through like a survey. Uh, I kind of mentioned it in class before, where the university would like to get your feedback, both on the lectures as well as the recitations. Now there's an extra dimension because we've gone online. So it's a little bit of transition that we had to go through. I know it's a big transition for a lot of people, so I think there's going to be some feedback that people want on that. So if you have a chance that you can fill that out, that'll be appreciated. Actually, let me see if I can just share the link on the chat. I'll also send it out to the class later too. Okay, I'll post a QR code in a second during the lecture also. So, this for today's lecture, I plan on covering the chapter 1, not chapter 1, section 1. So that was the beginning of the class. So everything that went into the first exam, I'll kind of run through that. I'll post some of my material that I'm working on. I'll post that up to the file section for the lectures under my file section, so you can refer to that. And then we'll cover stuff that we did for exam 2, as well as anything else for next week. So we'll get going with that right now. So I'm gonna share basically. You guys should have access to this, but we have a breakout of the learning objectives mapped to the exams. So I'll share that right now. So let me share. I guess I may try to share the whole screen. Okay, so here, this is the first one that we have, which is the learning objectives used for exam 1. If you go into the file section on Canvas, you should see this. So I'll just kind of run through this, and I'll kind of run through some examples. And then we can go through any questions you might have in this area. And then, like I said, for next week, we'll go into review sessions for stuff that you covered for exam 2, as well as the later stuff that we've covered, let's say the Excel and whatnot. Okay. Okay. So I think at the beginning part, there was different, almost like definitions that you went through. So there was stuff that was talking about feedback, consistent interface, metaphors. So it's like kind of like almost like definitions that you would just kind of memorize as part of your vocabulary. So I'm not sure I can go through too much of that. I think probably the most mechanical part was basically doing some conversions. And so that was like conversions between binary, decimal, and hexadecimal. So I'll kind of go through that a little bit. Let me put this down and go over to here. Okay. So what I've done here is I've set up a spreadsheet that kind of helps us to think it through. So of course we're going to be doing this exam online. So it's kind of straightforward for anyone just to punch in a hexadecimal to a decimal conversion and whichever way, binary to decimal. So it really can't just be like we ask you to do a conversion and then you just give a conversion. It's basically trying to demonstrate that you can follow a certain methodology to do the conversion. So I think you just have to be able to explain what's happening. So I kind of put together like a spreadsheet, and I'll kind of talk you through a little bit the mechanics of it. The fact that you can program the conversion into anything. In this case, I just happen to program into an Excel sheet. Like it doesn't really help you. It's almost like having a calculator or whatnot. I think the exam is really going to test more that you understand like what's happening. So I'll just kind of go over to here. So you can see this is the usual thing where you kind of scale up. On decimal, we know that's a base 2, right? So 2 to the 0 is 1, and then 2 to the 1 is 2, and so forth. So basically kind of goes up like this, 1, 2, 4, 8, all the way up. And so if you want to do like a binary to decimal conversion, this is the binary number here, right? And what you want to do is like for every spot that has a 1, you're going to basically bring it down to here, right? So that's why down here you have an 8, you have 64 and 128. And then you're just going to add all these up, and that's how you end up with 200, okay? So if I go here and I change this, right, let me change this, and let me just put a 1 here. Okay, so really the binary to decimal conversion, all you have to do is mark off all the spots and how they map to this binary mapping here. And then you add them all together, and then that's your decimal number. Okay, so you can see my formula down here. All I'm doing is taking this one and multiplying by this one. Okay, all the way through. Okay, and then over here you can see I'm just doing a sum of that. All right, so that's how you do the binary to decimal conversion. Now on the flip side, you may remember to go the reverse is basically taking the remainders. Okay, so now I have this number here, right? This is actually, this is what I want. So this is the decimal number I'm starting off with. I started off with 200, okay? And so the first thing I do is I go over here to the left and I do a division. So how many times does this go into this, and then what's the remainder? Okay, so that's why I have this formula here where I do a division of the 200 by 128, okay? And then you can see I use the mod function here. And the mod function is just your remainders. Okay, so if we kind of ask you to explain how to do the conversion, I think that's how you want to try to explain it. The fact that you can go from a binary to a decimal or decimal to binary, the answer itself is not really going to be tested just because it's easy for you to just punch that into a calculator. So so this idea of doing the division and then having a remainder, taking that remainder and then dividing by the next number and taking that remainder and carrying it all the way through is what you want to try to remember. That's like the algorithm, let's say, to come up with the conversion. All right, so that's the important thing. Try to understand that and be able to explain that. Okay, so we may ask you to do the conversion, and show something like this, where you show we did a division, you show that you did a mod, and then you show that you moved it all the way down. Okay, and really you kind of do the similar type of thing for a hexadecimal. So hexadecimal to decimal, same type of thing. Only thing that kind of maybe confuses things a little bit is the fact that it's a hexadecimal, which means it's a base 16. Therefore, you can see here, I have my little mapping on the side. I have hexadecimal and I have decimal. So base 16 starting at 0 means that the maximum number is 15 from a decimal perspective. And then from a hex perspective, it goes 0 through 9, and then A through F, right? And so you can see how that maps to get your 16 places for your hexadecimal. So let's say I'm doing a hexadecimal to decimal conversion. So similar to what I did up here in terms of the binary and taking that up to 128, I'm doing the same thing here with hexadecimal, right? So hexadecimal, 16 to the 0, 16 to the 1, 16 squared, and cubed, and so on, okay? So I put in just a sample number here. I put in like B and A, which obviously kind of maps over to here, 10 and 11. So I just set up a VLOOKUP to take this and get me to a decimal. Okay, so you can see if I do a VLOOKUP on a B, I would get 11. And if I do a VLOOKUP on the A, I would get a 10. Okay, so the reason why I need that is because I need to do some multiplication on it. So I'll take this, this 11, multiply it by this, okay, which you can see is exactly what I did with the binaries, the decimal, right? I'm taking these two numbers and multiplying it. So likewise, I'm doing the same thing here. I'm taking this number, multiplying by that, right? And then very similar to what I did with the binary conversion, I take the sum of every single thing here, okay? And likewise, when I do the reverse, it's very similar to this, right? Where you're taking the remainders, okay? Like I said, the only difference here is that you have this extra mapping of hexadecimal to decimal, okay? So I took this number here and goes to here, you got a remainder of 0, okay? So you can see, here's the division, right? So I took the J16, which is over here. This is my decimal number, right? And I divided it by this, which is a very large number. So it's not going to get anything. That's why you have a 0, okay? And then obviously the remainder is just going to be this number here, right? And then it kind of carries on exactly like the way we did up here, okay? Then finally you get over to here, and then you get 11. Right, well, 11 isn't in hex. 11 here maps to a B. So that's why I had to do this VLOOKUP here to convert this to a B. Okay, so that's how you end up with this BA01, which is BA01, which is what we started off with up here. Okay, so I set up this spreadsheet just to kind of talk you through and explain the whole idea of how it works from a conversion standpoint. So this example and this example, you're basically just marking off the places and then multiplying and adding them together. And then going the other way, you're basically using, I guess they call that remainders algorithm to come up with the conversion going the other way. Okay, so I'll upload this spreadsheet up to the files under my lectures. So you can look at it. Like I said, you're not really going to use this mechanically to come up with the answer. It's more to understand the algorithm to do this. So this is something that I think you will want to review for the exam. So this is a little bit different than the other sections, which is kind of more like memorizing definitions. Okay, so let me close this. All right. Oh yeah, so there's another bit here. You remember we did some stuff with colors and making pictures brighter and whatnot. So I just want to show you something that kind of maybe helps you to visualize this a little bit better. Okay, so you have this thing here where you can select all kinds of the colors or float over the colors, um, and then you can see what the RGB is, right? And it actually shows the hex over here also. Um, so I'll just share this link with you when I upload to the files later. But let's start with white. All right, so you remember what the white is. Um, you can see it's 255 across everything. Okay, and then let me just slide this all the way through until it gets darker and darker, and you can see how the numbers are shifting. Right, ultimately, let me get to black. And you can see how we talked about black being the absence, right, of the light, which is why you have 0, 0, 0. Right? And then you can kind of play with these different variations. Okay. And you guys probably remember from the exam, there might be some questions that kind of talk about, how do you make some color like more red or more green, or like black or white, more towards black, more towards white. If you play around with this a little bit, you can kind of see how the numbers move around, and that kind of gives you a feel to how to answer those type of questions. Right, so if I look at red, obviously you can see red is 255 all the way through, and everything else is 0. Okay, and likewise, if I go over here to blue, you get that. Okay, so I hope this type of table kind of helps you to visualize what we mean by like RGB and the values in there, what the low value is, what the high value is, and what that maps to in terms of what the color will come through will be. Okay, and there's a couple of different types of tools like this that you can use to help you understand how these color combinations come through. All right, so you have like the vocabulary here. Um, Probably good to understand like some examples of lossy compression. Um, you talked about we talked about different things where we reduce the number of colors that has some loss in the compression. And lossy compression, all that means is that you can't fully reproduce the original, right? So if you have lossless compression, obviously that means you can reproduce the original, okay? Um, and you talk about things like the Nyquist rule. Just remember that how many times you have to sample the sound to more or less reproduce the sound. What level of granularity, how much sampling, right? So usually at the highest end, you want to double that frequency to actually reproduce that sound. Okay. Um, yeah. So convert between the bases, binary conversion, hexadecimal to colors. Let me go back to here, just a reminder, so you can see the hex over here. Right? So whatever colors you have here is just converting to the hex also, right? Hex is just kind of a shorter way to represent that. So you guys remember what P and A, uh, metadata, brightness, contrast, and frequency, how much, like we were just talking about, sampling uh, and the sampling rate, run length for coding, um, don't know if you remember, so the run length for coding would be like if you have a whole bunch of zeros and ones, there will be repeats, and you would just kind of say, well, okay, for the next however many sequence, you have this many. So if there's like, 10 ones in a row, you would just be able to mark it off and saying like the next 10 is going to be 1. So that's a lossless type of compression, and that's one type of compression. Okay, and for the exam one, the other thing that was kind of notable was really around HTML. So you remember from the exam, I think we had a reference sheet which kind of laid out a lot of the different tags and whatnot. You just need to be able to use those tags. So probably what will happen at the exam, we'll probably have like snippets of code, snippets of HTML, I should say, and then you would try to either one, identify if there's an issue, right? Maybe it's not complete syntactically, or you try to show what that image, not what the image, what the HTML would look like. Okay. So probably things around tables. I think I have something here. Oh, by the way, this is the QR code for the survey also. Okay. Oh, and one more thing. There was some people asking me about extra credit. So I think the last quiz on social implications of IT. Again, it's just a quick sample quiz. You can take that, and then that will be the last of the extra credit. So let me see here. So I have some code here, and I did a couple of different things here. So this w3schools.com, I think, is a pretty good resource. I think it's been listed out there also. So almost every single thing you can think about with HTML, there's an example of it within this website. So you can play around with it, and you can go into like this screen like I have right now, which has the editor, and then shows you what it looks like over here. So you can see this part over here. You have the HTML, and basically you have, this is the URL, and then this would be what it looks like on the screen here. So it says visit our HTML tutorial, and then you can just click on it and then it'll go to this URL. Okay, let me just click on it just to show you. All right, so kind of straightforward there. The other thing that's fairly common is this image, right? So here you have the image, and gives you like the description, gives you some settings on the width and the height, and then from a style perspective, it draws a black border around it. Okay? So that's kind of gives you a little bit of everything in terms of the image and how to present the image. There's other things you can put in here in terms of, center, top, or wherever in terms of alignment. Okay. The next bit, which I think there's all kinds of different variations to play around with, it is the table. I think you probably remember that from exam one. We did quite a bit of different variations on the table. So one thing we put up at the top here, and from a styling perspective, is to set up a border. So you can see the border here, and just do a solid black. You do the 1px here or whatever, that's not really gonna be factored into the exam. I know there was some question in one of the exam one questions about like looking at the image and saying, okay, what exactly is that color, or what's that font size or whatever. I don't think it's reasonable to be able to translate that into an exact number. So you just kind of have the right idea of the syntax to do it, and that's the important thing from a test standpoint. So So you remember, here's the definition for the table. Here, you remember the header, right? So you have the TH for header. You have the TR for the row. Here's the TR, and then the TD, which is basically like the values within each of the cells. Now that you're showing as a table with the borders, you can see the cells almost like your Excel sheet. And so within each of that TDs, you can put this, which lines up to this. Okay. All the other stuff with HTML, I mean, I could go through the sheet, but it basically lists all of those. Let me go back to my files here to see where was that. Oops, it was like a reference sheet, I think, or maybe it was in the modules. Yeah. Okay. So under modules, you can see the reference sheet. So this was the sheet that you can work off of from the exam one. All these different things to reference. Okay, so just be sure that you can refer to this and be able just to leverage these as examples to answer the questions here. Right. So let me go back to here. All right. Some of this other stuff is related to kind of the definitions again. So you know what a client server structure is, tying back to what we discussed recently, how we might use cookies to simulate a continuous connection. Um, we're not actually doing that, and whether we're communicating synchronously or asynchronously, given the response time on the internet, we can simulate a synchronous conversation when actually it's an asynchronous conversation. Here, let me see. Yeah, so they're talking about technologies, asynchronous versus synchronous. Um, how do we broadcast? Um, so remember point to point, it's almost like I make a connection with you directly, point to point. Um, and then multicast is more of like a subscribed group. So maybe like your recitation, like a group of distinct people or subscribers, I can say. And broadcast is almost like universal, like everybody pushed out. So those are kind of like the different levels in terms of messaging there. Local area network versus wide area network. You probably know that is sort of like within a building or campus. You can call that as your local area network. A wider area network would be across like a region, like some big geographic area. So that would be like a wide area network. Okay, so just definition of why, just remember computer, modem, router, how they hang together. So basically, if you have this set up in your home, you will probably go from a computer to the router to the modem. Okay, and of course, from a wireless standpoint, your wireless goes into your router, and then your router goes into your modem. Um, and then you have your ISP here. Okay, and then you have internet gateway. Um, So you remember like the domain DNS, domain name server, right? That's how you map the names to specific IP addresses, okay? Might want to just review how the web search engine works. There's probably those Venn diagrams. You remember how the ands and the ors. I know we probably hardly ever use something like the ors and whatnot, but there's probably going to be some Venn diagrams to talk about what type of results you would expect depending on how you do the queries with the and the or. Okay, how do we do the ranking? We talked about that in conjunction with HTML. How do we tag the metadata on there so you do better on the ranking? The other thing is in terms of referrals or links, backlinking. So how does that improve the page ranking within Google? Yeah, here we go. So W3 schools. This is like I said, a good reference here. All kinds of examples. You want to just maybe review that pretty quickly, and also review the CSS. Okay. Okay. Now if I should maybe review absolute path and relative path, I think there was a number of people that happened to get that incorrect for the exam. So basically the absolute path is like the full path, the full URL in this context. And the relative path might be, so wherever you're starting from, let's say wherever your directory is for the web page, let's say where your index HTML is, either go up or go down the tree, right? So you have like remember a tree structure. Maybe I should try to put that somewhere here. Yeah, I'm just gonna type in something here. So you remember like if you do like something like that, uh, I actually even have something here, right? So you go how many levels up the directory tree, okay? So that's basically for relative path. So wherever you're starting, you put this in, that's how many levels it would go up. And if you kind of go the other way where you put it with the name of the folders and you go down the directory tree, you're going down, okay? So you can actually go up and down depending on what you're trying to do or get to. So the idea with the relative versus absolute, like I said, absolute is going to be the full path, okay? I lose that here. Here we go. So absolute path is the full path, the full URL, let's say. And the relative path, if you want to go up the tree, it's like dot dot forward slash. If you want to go down, it will be a forward slash with the name of the folder and forward slash, depending on how many folders you're going to go down. Okay. Let's see, client server. Yeah, we know about that. Cookies, IP address, internet protocol. Packets, those are the bits of information that goes across. So you remember I have a document starting at point A that gets broken up into bits of information, packets. It goes to the destination, gets reassembled. TCP/IP is that guaranteed delivery. Wide area network, local area network. Ethernet, wireless network router, modem, ISP, internet service provider, DNS, domain name service, redundancy, caching, World Wide Web, search engine, web crawler. Remember the web crawlers to go out there, go through the pages and help you index them. There's certain pages that would not get picked up by the web crawler. Boolean, right? So we know Boolean off and on, 0 or 1, P and A, logical operators. Let me see here. All right, HTML. Okay, and then towards the back end here, there's a bit more stuff about just kind of understanding various bits and pieces, like the names of certain people. So it talks about different parts of the computer. Oh yeah, that was the other bit that was on the back here that maybe people didn't remember as much. Maybe you want to review that. Is the fetch execute cycle. So you remember you have the memory, that's where all your information is, whether it's like the actual data that you're going to be working on or the steps for the program. The control unit, which is kind of managing this process. The ALU, that's where the actual calculation happens, the arithmetic logic unit. The IO, input output, right? And the program counter, right? So that keeps track of the next step that you're flowing on the program, unless you're doing like a redirect, it will skip to another part, let's say. Yeah, CSS, the style of the web page. Yeah, if you have a chance to look through this, just a timeline of how things are getting smaller. So notable things like starting off kind of mechanical computers, but then going into vacuum tubes. Then the next big leap was into transistors, and then really going into more integrated circuits. And really all that led to more compressed space to basically do your computing. So everything getting smaller. See here. So yeah, these are things to memorize, or well, maybe not memorize. I guess you'll kind of have something to look at. So just kind of look up these definitions if you're asked. I don't know how many of those type of questions you'll be asked. It might be just more how do things interact together, right? So know what the program counter is doing and how that fits in terms of feeding information into the ALU and ultimately going out through the input output. RAM was that random access memory. Just trying to see here if there's any notable things to try and explain. For example, the material covered for exam 1. Okay, so I think that kind of runs through like everything for exam 1. Let me see if people have questions here. Okay. Yeah, so I'll be posting the stuff that I have here. There's a lot of links for different things as reference that you'll see also. So that's already on files, but if there's anything that you need more understanding on for the material for exam 1, just let me know and I'll try to get the material for you. Okay. So the format for the final exam, I think it's kind of similar to what you experienced for exam 2. So you'll have the 24 hours. You won't be able to go back. Once you do the question, you submit it, you have to keep on moving forward. You won't be able to go back. But I think there was some discussion about making each of the sections timed, and we decided not to do that. So that's still basically going to happen the same way as we did in exam 2, 24 hours. I'm trying to think what else we had. Yeah, there was some like short answers. So like I said, between um, like the multiple choice, and when you say multiple choice, that also can mean true, false too. Um, and like the short answers in that regard is pretty similar to the other exam, the exam 2. And there was a bit about the code. Um, So I think some people had some difficulties turning in the code for some reason. So just be mindful of that. So pay attention to uploading the code, and don't submit it unless you're sure that that's what you want to submit. Because we can't back things out once you've been submitted. Okay. So yeah, you'll have a section to submit just like last time. Okay. Any other questions? Let me just scroll through here. Okay. All right. So if there's no other questions, I'll let you guys go. And like I said, just come back to me if you need any more pointers or whatnot for exam 1. Okay. Thank you.